A battery that could transform everything from electric cars to flying drones has just been unveiled in China, and honestly, it's already breaking records. Scientists at Tianjin University have created a lithium metal battery that reaches an incredible 600 watt-hours per kilogram of energy density, which is more than double today's lithium-ion cells. So, why does this matter? Well, it could mean electric vehicles with ranges once thought impossible, and drones that stay airborne for hours. Researchers at Tianjin University have achieved what many considered a distant goal: a lithium metal battery delivering over 600 watt-hours per kilogram of energy density, branded Battery600. To grasp its importance, today's commercial lithium-ion batteries generally sit between 250 and 300 watt-hours per kilogram. This means the new prototype more than doubles current standards. Alongside it, they introduced Pack 480, a modular pack at 480 watt-hours per kilogram, designed to bridge the gap between lab results and scalable products. The key lies in solving lithium metal's long-standing challenges. Conventional designs suffer from dendrites, needle-like structures that grow on the lithium anode, causing short circuits and safety hazards. They also struggle with interface instability and short cycle life. The Tianjin team tackled these issues with a fully decentralized electrolyte formulation, which balances interactions between solvents, anions, and lithium ions. This creates a disordered solvation microenvironment that stabilizes the electrode-electrolyte interface while improving ion transport. Project lead Professor Hu Wenbin explains that this balance reduces kinetic barriers, allowing smooth lithium plating and stripping, which is critical for safe, repeatable charging cycles. Published in Nature in August 2025, their results showed remarkable cycle stability, thermal safety, and structural scalability. What makes this especially important is that these are not isolated lab cells but pouch cells and modular packs already proven to work. In short, Battery600 and Pack 480 demonstrate that lithium metal batteries can finally reach the energy densities promised in theory, with practical stability and safety. It's a scientific leap that paves the way for industrial-scale applications, marking a new frontier for energy storage technology. What separates this breakthrough from countless lab-only announcements is that it's already powering real devices. Tianjin University's team installed Battery600 cells into 3 small UAVs, where they achieved flight times nearly 2.8 times longer than drones using conventional lithium-ion batteries. That's not just more minutes in the air, it's a step toward drones that can perform longer-range surveillance, mapping, or delivery missions with reduced recharging needs. For electric vehicles, the implications are dramatic. Current EVs average ranges of 400 to 600 kilometers per charge with lithium-ion technology. With 600 watt-hours per kilogram density, those ranges could double or even triple, pushing into the 1,000 kilometer zone without increasing vehicle weight. The term range anxiety could fade as ultra-long-distance EVs become practical. Beyond vehicles and drones, other fields stand to benefit. Robotics could operate longer on lighter power packs. Consumer electronics from laptops to wearables could become thinner yet last much longer between charges. Even aerospace systems could use lighter batteries to improve efficiency. Safety, often the Achilles heel of high-energy batteries, has been rigorously addressed. Battery600 cells passed extreme stress tests, including low-temperature operation, nail penetration, and open-flame resistance. These results indicate that the system maintains stability even under conditions where conventional lithium-ion might fail. To prepare for commercialization, the team has already established a pilot production line for high-energy lithium metal batteries. This means scaling isn't just a plan, it's underway. The Tianjin University breakthrough doesn't just represent a technical milestone, it carries weight on the global stage. Consider the numbers. Tesla's 4,680 cylindrical cells deliver about 300 watt-hours per kilogram, while BYD's popular Blade battery is roughly 150 watt-hours per kilogram. Battery600 more than doubles Tesla's performance and quadruples BYD's, setting an entirely new benchmark for energy density. China has already set national goals for next-generation energy technology under Made in China 2025. Their target for EV batteries was 400 watt-hours per kilogram, a figure Battery600 has surpassed years ahead of schedule. With a pilot production line already operational and full-scale manufacturing expected in the second half of 2025, This is not just a research highlight, it's a pathway to industrial dominance. For global industries, the implications are huge. If China scales this technology successfully, it could redefine the EV market, setting new performance standards and reshaping consumer expectations worldwide. Drones, robotics, and electronics powered by such batteries would also shift competitive landscapes in multiple sectors. However, challenges remain. Cycle life, cost efficiency, and reproducibility at scale are still hurdles that need to be overcome before widespread deployment. Yet the evidence so far, peer-reviewed publication, UAV testing, and pilot production, suggests that these obstacles are actively being addressed. The significance goes beyond numbers. By achieving over 600 watt-hours per kilogram, China now holds a clear lead in the global race to master lithium metal technology. This could cement its role as a central supplier of high-performance energy storage, influencing not just technology markets but also the broader clean energy transition. The discovery of Battery600 and Pack480 is more than a step forward in research. It's a glimpse into a future where energy storage no longer limits innovation. From electric cars that travel for days on a single charge, to drones that remain airborne for hours, this technology could transform how we move, connect, and explore. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. And don't forget to leave a comment below. Thank you for watching and see you next time.